Hello, my name is Dongyun, a PhD student from Utah State University. I'm glad to introduce PDViz, a visual analytics approach for political scientists, on behalf of my co-authors. Federal and state policies influence our daily lives, including the welfare, education, economic outlook, and safety within the nation's borders. National and sub-national governments implement a variety of policies to address societal problems and needs. This diversity offers tremendous potential for governments to innovate and learn from the creative approaches of others. As the governments repeatedly face similar political situations, it is important to understand underlying policy adoption mechanisms for a sustainable future. Understanding the potential and dynamic interdependencies between society members is one of the major topics in the political science field. Political scientists have made great progress in understanding them. According to Traumiller, the uses of visualization in the field of political science is expanding these days. However, we find that their analysis highly depends on computational algorithms and uses static visualizations only as a reporting tool. To support their analysis by using visual analytics approaches, visualization researchers and political scientists worked as a team in this work. We began by collecting and reviewing literature in order to identify research tasks that political scientists have. Our political scientist member reviewed the tasks, and the following tasks are identified. Task 1. Summarize policy adoption records and diffusion patterns. Task 2. Explore policy diffusion in geospatial and temporal context. Task 3. Explore and compare policy diffusion in topical context. Task 4. Analyze policy diffusion in social and political factors. Here is our system pipeline. The pipeline has three items: data, data analysis, and visualization interface. Two political and social datasets are used in this work. The first data is State Policy Innovation and Diffusion Database, called SPID. It includes a total of 724 policies with 20 topics that spread across 50 U.S. states from 1691 to 2017, along with the 17,824 policy adoption records. These records make a policy diffusion network. The second data is Correlates of State Policy Project Dataset, called CSPP. It includes more than 2,000 variables of the political, social, or economic factors from 1900 and 2019. 14 factors among them, such as the percentage of foreign-born, crime rate, and urban population, are used in this work. Next, 4 computational analysis methods are used to support political scientist data analysis. NetInf is a network inference algorithm. It is used to infer underlying policy diffusion patterns in the policy diffusion network. State Innovativeness Score is a measurement of a state's willingness to adopt policies sooner or later than others. A state with a higher score is considered innovative, and it is more likely to adopt new policies faster compared to the others. Network centrality metrics are widely used to evaluate the relative importance of nodes in a network. In this work, 5 centrality measurements including degree, in-degree, out-degree, closeness, and page length are measured from underlying policy diffusion networks. They allow users to examine a state law in a given network. For example, out-degree centrality allows users to identify a state that has impacted others in the network. Finally, the Cox model is a widely used analysis model in the political science field. We fit our Cox model using SPID and CSPP. It computes the probability of policy adoption for a U.S. state and a policy based on context factors over time. PDViz is a visual analytics tool for political scientists to interactively analyze the policy diffusion history and underlying patterns. We use React and D3 to implement its interface and use Python and R together for the backend. In the following slides, I'm going to introduce visual elements of PDViz. The interface is divided into three views. A. Policy diffusion analysis view. B. Map view. And C. Policy adoption view. They are coordinated, and user interaction in one view affects the others. The policy diffusion analysis view is designed for users to analyze the policy diffusion patterns by state and topic. This view has the policy diffusion chart and policy metrics chart. It presents two different levels of details by following whether a user specifies a topic to analyze or not. I'm going to first introduce the case when a topic is not specified. The policy diffusion chart presents two underlying patterns, up and down. The upper passes are general patterns for all the topics, and the lower passes indicate patterns for a specific topic, which users mouse over in the policy metrics view. State abbreviations and color-coded glyphs are aligned in the middle of the patterns. The colors represent the degree of measurement. When users mouse over a state abbreviation or a glyph, patterns starting from the state are highlighted in one of blue, red, and purple colors. The colors indicate outgoing, ingoing, and bidirectional patterns. Next, the policy metrics chart is a heat map style overview. The policy metrics and policy diffusion charts are vertically well aligned, and they share the same x-axis. Its y-axis represents the policy topics. The blue and red color intensities on the cells represent the relative numbers of new policy creation and existing policy adoption, respectively. Mouse hover interaction allows users to explore underlying patterns by topic and state. For example, when a user hovers the mouse over the cell for state Utah and policy topic domestic commerce, the view shows how many policies Utah created and adopted. It also shows underlying patterns of Utah. The upper passes present general policy adoption patterns of Utah, and the lower passes show Utah's patterns for the topic domestic commerce. From these two passes, users can figure out their differences. For example, while Utah affected Illinois in general, a different pattern could be discovered for the topic domestic commerce. When users specify a topic in the top left panel, the view is updated. The upper passes in the policy diffusion chart now show a topic-specific pattern, and the lower one is a pattern for a policy, which users mouse over in the policy metrics view. The policy metrics chart shows how policies spread across the U.S. states. Its y-axis represents policy items. The blue circles in each row indicate candidate states considered to have first credit policies. Red circles indicate states which adopted a policy from other states. When users hover the mouse over a policy label in the y-axis, a tooltip appears, and it shows a list of contextual factors along with its associated Cox model results. It allows users to examine how much the social factors affect states to adopt or not adopt a policy. For example, a user can see that state innovativeness scores and foreign-born are most likely to influence states to adopt a hate crime policy. The map view shows geographic information with degree of measurements in colors. It allows users to analyze neighboring effects on policy diffusions by examining geographical proximities. It provides two styles of map, the US state map and a hexbin map. PDViz additionally provides the hexbin style map, presenting measurements in the same size of shapes. It helps users avoid misinterpreting the measurements due to the state sizes. The policy adoption view presents policy adoption trends. It has 4 tabs. The first 3 tabs provide bar charts showing the number of policies that are newly created or adopted from the other states by year, state, and policy topic. The last Context tab provides a line chart representing social vectors. The green line represents the line chart of state a user is interested in. In this case, the green line represents changes in foreign-born residents in California over time. The black line represents the US average, and the gray lines represent the foreign-born changes in the other states. It also includes small blue and red boxes with state abbreviations written on them. The blue and red boxes are located when the states created or adopted the policy respectively. In the following slides, I will introduce by context tab in detail. By context tab is especially coordinated to the policy metrics chart. As I explained earlier, the tooltip in the policy metrics chart could tell users which social factors have highly impacted for states to adopt a policy. When users click one of the factors, the By Context tab shows the line charts along with 3 settings based on what policy the user explores, which state first creates the policy, and which factor the user selects. First, users can examine when California first created the hate crime policy. When users hover the mouse over the blue box, another tooltip presents what its foreign-born value was with the US average. Next, users can explore which states adopted the hate crime policy after California created it. The chart says Oregon and Washington adopted it next, and New York, Massachusetts, and other 3 states are also followed after them. The tooltips show their foreign-born values. To evaluate PDViz, we present 2 user scenarios and conduct a user study with 2 political scientists. In the following slides, I will briefly present the user scenarios and expert feedback results. The user scenario 1 is examining policy diffusion statistics and state roles. First, when a user sorts the policy by number of total adoptions, the views are updated. On the policy metrics view, the y-axis is aligned in the order of total adoptions. The user can identify the topic law and crime is listed first. In the policy adoption view, the by topic view also shows the same result. Next, when the user hovers the mouse over the label in the metrics view, its interaction affects the other views. For example, by state chart in the policy adoption view now shows how many states adopted or created by state. The user can check California, Colorado, North Dakota, and Washington created many law and crime policies. The measurement of network centrality and state innovativeness allow users to infer their roles in the policy diffusion. For example, a state having a higher degree centrality score could be considered as a state which has actively influenced and being influenced across the policy diffusion network. Here, California has the highest degree value in general and for the policy topic of law and crime. Similarly, other centrality metrics enable users to investigate various laws in the diffusion network. Next, by examining the upper and lower passes, users can identify underlying patterns of California. It generally has outgoing and bidirectional relationships with most of the states. Similar relationships could be found for the law and crime topic, but one ingoing relationship appears between California and Montana. I introduced simplified versions of user scenarios. For the detailed scenarios, please refer to our paper. Next, expert interview procedures and feedback results are reported. We had an introduction session with 2 political scientists in a virtual setup. They are the experts in American politics and political methodology and have long been doing research on NetInf and SPID. The introduction session took an hour. We introduced the PDViz interface and demonstrated 2 user scenarios. After the session, they completed the study individually. They were asked to answer demographic questionnaires first and complete the user scenarios themselves to recap the PDViz functions. After that, they were asked to use PDViz freely and complete usability questionnaires. E1 commented that PDViz was helpful to understand systematic variation in diffusion patterns across states and topics. He stated that the policy analysis view is his favorite since it efficiently summarizes a lot of information and the colors condense information well. At the same time, he pointed out that diffusion does not necessarily imply causality, and users might need a domain knowledge for using PDViz. It too commented that PDViz is well aligned with his domain knowledge. He stated that the map view is his favorite because it is familiar visualization for him and it works as a good starting point for his exploration. He said PDViz is an interesting tool to explore the diffusion patterns, but pointed out that the illustration of the diffusion networks could be improved. PDViz is originally designed for political scientists. Interestingly, the domain experts remarked that the visual tie metaphor in PDViz could help students understand the fundamentals of policy diffusion and the law of states in policy diffusion. It refers to a potential use of visualization techniques for educational purposes. The red and blue colors are widely used to refer to political parties like Republicans and Democrats. For our color choice, the domain experts noted that the colors condense information well and are useful for understanding diffusion patterns. It shows that the reasonable use of colors could help the domain experts do their analysis works with no confusion. In the expert feedback, E1 pointed out that users might be interested in comparing diffusion pattern changes over time. They might even want to compare patterns between more than two topics or policies. PDViz could help users examine diffusion patterns and compare patterns hierarchically, but is limited to supporting the analysis which E1 pointed out. In this work, we use the computational algorithms such as Cox model and network inference with their default parameters. Optimal parameters for the algorithms are not clear. However, allowing users to change them in the interface would be helpful for their analysis. The following are the conclusion and contribution of this work. This work introduced PDViz for political scientists to analyze policy diffusion patterns in relation to social and political factors. To implement a system for political scientists, we present a data-driven approach pipeline along with the domain data and analysis methods. Finally, we evaluated PDViz by presenting 2 usage scenarios and conducting domain experts interviews and report lessons learned. This is all for our presentation. Thank you for your attention.